Hello, thank you for joining. My name is Reinhard Seidel. I'm founder and CEO of Deeptronics. Today, we're going to have a great panel discussion with two excellent experts on PCB defects and how we can make them visible before they potentially give some errors and issues. To my left, I have Victoria Rawinski. She's founder and CEO of the Rawinski GmbH. She has years and tons of experience in material analysis for electronics manufacturing, and especially specialized in product recalls and those really critical cases. She is also a speaker on global stages and also a technical committee member of SMTA International. Welcome, Victoria.
Thank you for having me here, Reinhard.
You're welcome. On the far left, David Dudek. He's head of training at the great company Trainalytics. It's also quite well known for its trainings and analytical competence and expertise. We are going to discuss PCB defects today. Like, PCB defects can vary a lot. You might see them just by the symptom of wetting or de-wetting, soldering bridges, until hidden risks like delamination and voiding. And the question, challenge is, how can we identify those risks and how can we make those risks visible such that they don't grow more dangerous and potentially harmful to life of people? My first question, just to get to know you a little bit more, what PCB defects, PCB-related defects, do you think or feel is most fascinating? What still holds you in awe? And maybe on the other side of the coin is frustrating to you because you see it all the time and costing people money. Maybe. Victoria.
So that's a very good question. Thank you for this, Reinhard. And we have a pyramid picture on this just to show you which kind of defects we see and what is the root cause of this. For example, if we see defects like warpage in soldering process or maybe some wettability problems, it's just what we see by eye. The root cause may be the humidity interaction or humidity penetration through the solder mask or humidity interaction of photoinitiator during the manufacturing process of the solder mask itself. And we cannot see effects like this. From my experience, humidity is maybe the most evil thing which can happen during the manufacturing process and also lead to product recalls afterwards. Even the product is maybe, for example, for 4 or 5 years in the field, leading to electromigration, to penetration, corrosion between the PCB layers itself. So humidity is, from my opinion, is the most evil thing.
Most evil thing, all right. David, do you have some specific defect that you, let's say, like most or kind of enjoy, although it's for the bad of your customers?
The defects I love are typically separation defects in the inner layers of the printed circuit boards and delamination because they are really easy to find. And I agree with Victoria's talk because humidity is one of the main problems we see in the field application. Defects like conductive energetic filament growth or something like that depend directly with the humidity which goes through our protecting layers of the PCB in the inner of the printed circuit boards, and this will cause to drastic field defects.
So do you feel that there are specific defects, possibly those the already mentioned defects are those, but are there defects that kind of seem to go away because people or organizations learn from their errors and their issues? Like, what is the root cause of the defect? Is it people doing wrong designs, doing wrong processes, or is it hidden variation in materials that you, which is actually really hard to control? So this ultimately no one's fault. How do you feel? Like, you would probably see, or the defects you were talking about are visible with our eyes. How do you feel about that? Do you see all the time the same thing, or is it improving or changing over time as also electronics applications change?
Perhaps you can switch to my slide with the specification tree. Then for this one, the next one. Here we see a connection between the design of an electronic assembly, the printed circuit board, and the printed circuit board assembly. In every step, we need trained people to get reliable products. And in every step, it's possible that we can get some defects. Early defects depending on wrong material decision, or defects within the printed circuit board production, and in the end, defects during printed circuit board assembly. Perhaps we can go to the other slide with the defects within the printed circuit boards. Here you see an overview which defects are possible only in one plated through hole. That means every defect has another root cause, and we must know how these defects are formed and make some actions to prevent them.
What I see from my daily work on this topic is that the human factor plays a major role. Most of the mistakes or ignoring quality parameter are from the human side. And the resulting problem is from the manufacturing processes time. If for example, I have a picture on this with quality problem number 1, which demonstrates what can happen if we have from the manufacturer side an incompletely cured solder mask. You cannot see the PCB look green and shiny before soldering, also through whole wave soldering process application. But after the soldering, we can see some residues which can, for example, not be cleaned. Why? Because an incompletely cured solder mask could not react completely because of the reducing of one manufacturing step by not applying enough heat. But during the wave soldering process, this solder mask, incompletely cured solder mask, get enough heat to complete the reaction and goes in interaction with the flux. And that results in one mixture, polymerized and cross-linked mixture, which makes it impossible to be cleaned.
Right. So you say that, and this is probably also the danger, that those chemistry not being treated as it should causes invisible defects on molecular level, let's say, which
yes, exactly.
later occur or are the reason for manufacturing issues, which are then potentially, let's say, machine manufacturers are blamed, or the manufacturer itself, like the EMS company, is blamed because although their supplier actually did something wrong. Like, as we go throughout the supply chain, starting with the PCB substrate and prepregs, copper foils, and so on, how, like, we were discussing a lot about humidity now. How does that propagate from the PCB from the base material to the PCB into the manufacturing? What measures are relevant in the manufacturing process to avoid this? And, sorry, this is the second question, which is tightly linked. Is the electronics designer, what mechanisms does he have to know such that he can make better designs potentially to improve that? So all of that design for manufacturing, which will be topic tomorrow, but is there something that we can do on a materials level already?
Yes, we can. People should get a basic understanding which processes are important, which processes during the manufacturing of the PCB plays a major role. And we should respect the rules of this universe, of the chemistry and also the physics. We cannot undergo the rules. If a curing process needs some temperature window and time window, we should respect this. We cannot just shorten the time and increase the temperature. The product will fail.
Right, so we can't trick physics. That's
yes.
Perhaps one additional sentence. Of course, the designer must know what will happen during the PCB production. What's about the process temperatures? And the designer must choose a material which is able to survive the soldering process. And the PCB manufacturing has also something to do with cleaning. It must be possible to clean risky residues completely from the printed circuit board assembly to get a reliable product.
So I assume if I design a PCB, I have a certain application in mind, let's say motor control in automotive, or maybe a handheld device in an industry application. So I have some certain operation conditions, environmental conditions in which the product has to work and function. Is there wrong substrates, or is there substrates? Yeah, so you can basically just do an error in terms of choosing the wrong substrate for the wrong application, or is it there's substrates or materials that should not be used at all?
Yes. If we have a look onto the typical lifetime of a product, it's shown as a bar tube curve. That means in the first section, we have typically early failures. That means if we choose the wrong materials for our product, we will see really early failures. After that, the second section, only random failures occur. That means dirt particles or something like that, or lots of humidity, and in the end we have wear out failures in the third section where the bar tube curve rises again. That means we have 2 points. One point is the emission profile during field application. The other point is the necessary temperature or the necessary parameters during printed circuit board production. That means it's the material we choose must survive the process parameters, even if we have huge components onto them.
What I see also from my daily work and from my lab bench is a quality problem number 2, which is non-wettability on solder pads caused by also humidity and ignoring by humans during the manufacturing. In this case, we have a thin layer of the solder mask covers the entire PCB surface, and it is invisible. And you cannot measure it electrically because the needle goes down, pushes the thin layer of the solder mask from the solder pad away, and you will get great electrical results. So this product also look beautiful, shiny, green. You can print it without any problems. But the disaster is just visible after the soldering because you have solder bead formation, you have non-wettability. And what I see or what my customers try to do is cross-section and analyzing the intermetallic layer and just wondering what is the problem. So the basic understanding is very, very important from my point of view.
So you're referring to the basic understanding of the designer, what can happen, and then in production, like I would say in assembly, because in assembly, if errors, and this is now probably the sequence that you would work together, is you see some issue, or your customer sees issues in the manufacturing, like de-wetting, like bridging, like whatever, and then you would go down and think about the potential mechanisms that can lead to this phenomenon. And when I understand you right, like the number of phenomena that can originally your root cause these issues are just a few handful, but the effects can be extraordinarily many different, as we just saw on the slide, right? So is it good to have kind of a precaution to early in qualification of your manufacturer of PCBs, for example, identify its quality, its footprint or fingerprint, and then in a second step in series applications, potentially without noticing, continue this audit?
It's not as simple as that, because the PCB manufacturer maybe doesn't know what's going wrong, where the deviation is. If you have, for example, some interaction of photoinitiator by manufacturing the solder mask with humidity, and the humidity amount can be a little bit too high to result in non-cross-linking and non-polymerization of the solder masks. If you don't detect this humidity level correctly, you have no chance. You will see a shiny and green solder mask, but it is not completely chemically reacted. So even the PCB manufacturer maybe doesn't know this.
Right. And what do you think, like, are the issues arising more, like which assembly process is more stable? Is it more through hole? Is it more pin and paste? Is it SMD? I mean, obviously SMD is from the absolute amount of components placed, is the predominant technology, though through hole, at least in Europe, still plays a decent amount of decent role, because we are dealing with a lot of power electronics, which are not applicable to SMD components. So do you feel there is there's a shortcome in through-hole in through-hole stability and robustness in the process because of such effects, root causes?
Usually the through-hole process is a second process if you have already your reflow process done and you cannot see some deviations from the process. The through-hole process will go well, but the first process is a reflow process. So if you have maybe some deviations on the PCB side, like solder mask coverings the entire surface, you will see it at reflow process first, not even before the THT process.
Perhaps another point, if we have a look at the different end finishes, which we typically use for printed circuit board manufacturing, the designer must know how many process steps will occur. And we need a good quality during printed circuit board manufacturing to survive these processes. As an example, if we think about the commonly used electroless nickel immersion gold surface, it could look perfect from the outside. But if we have a deeper look into it, it's possible that we see some cavities within the nickel layer, which will cause nickel corrosion, and wettability is not more given. Another surface, let's talk about immersion tin. If we have many soldering processes, 1, 2, 3, perhaps a baking process too, the intermetallic phase will grow. And this could happen in a non-wettable product too.
But what most people overlook is also a very good point, is also if you have solder traces over the solder pad and you solder it in the reflow process, you create a lot of nucleus in your solder joint, additional nucleus, and the behavior, mechanical and chemical and also thermal behavior of your solder joint will completely change.
I understand. So when you do microsectioning and analysis of these things, like how do these preconditions, like not good preconditions, to what extent does that affect our industry and the, let's say, competitiveness of our companies? As the great problem, and I don't want to repeat that because it's all everywhere that at least European PCB manufacturing is close to dead. I still feel we need to trust other manufacturers, and we still need the know-how about the processes to be able to judge and to understand how the processes should look like, to compare them with how they do look like. Like, what should or how can we as German or European companies make sure we actually don't bring bad products to the market but still be competitive? So I feel that is a paradigm we should somehow solve. And as we don't have the PCB manufacturers anymore, we don't have the know-how. How could we solve that? And how would you approach that?
Of course, we will first talk with the PCB manufacturer. And the next point is we need testing. We need to have an information if the product we need for our printed circuit board assembly is good enough to survive the mission profile during field application. That means if we talk about complex products, we of course must see that every technology used during PCB manufacturing worked good. This is something to do with cleaning, with remaining residues onto the PCB surface, and this is something to do with the structural integrity of the printed circuit board assembly after thermal stress testing. For me, it's not important to check the quality directly after printed circuit board manufacturing. I want to see that the printed circuit board works how it has to work after the soldering process. And this is something what we must, what our suppliers must give us.
And of course, we should bring the PCB manufacturers back to Europe.
Yeah, that is obviously a great wish. That will be probably in other hands also how that is going to evolve. But I think the first step is to try to keep know-how, to have a sense for what is important, and without competitive products, let's say, it won't be feasible to bring it back, because obviously the margin would have to be very big to be able to make that effort. Now, when we come to those effects and how we as a developer company, how we treat that, I think probably training, or how do you see the understanding of the companies that training is required also for PCB like IPC A600, even though we don't have the manufacturing here anymore?
this is a big problem. I agree with Victoria, as she said, we must bring PCB manufacturing back to Europe. If we do not so, we will lose the know-how. We see as a training center that the number of trainings we typically give per year goes down. And this is directly correlating with the number of printed circuit board manufacturers remaining in Europe. This is one big point. And if we lose the know-how, it will never come back.
And probably the designing companies or the developer companies like Siemens or like the big ones, if they don't have the know-how and the sense for the importance of this know-how, it's probably also going to be hard to at some point, like because the small companies, they cannot afford that, right?
One point, of course, such a big company like Siemens or something like that has know-how, but is this know-how placed in Europe or is it placed in other countries? This is a big problem.
All right, thank you very much for the moment. For the last question, I have one last question, and I would be interested in like which root cause or which problem on a deeper level, on PCB level, or maybe even materials level, would you like to eliminate, which would make life of the companies easier? Obviously, your analysis business or lab business would possibly suffer. But what do you feel is really endangering our competitiveness?
Okay. From my point of view as a laboratory, I hate conductive analytic filament growth because it's nearly impossible to detect it directly. It needs so much effort to find this issue. And this is one point when we think about the power electronics, which goes in field application, which can be a big problem for product reliability.
Very good point. From my point of view, the most critical factor is human factor. People know that they do something wrong and they just ignore it. Or the problem is cost driven. They want to buy PCBs cheaper, even cheaper than cheap,
Sure.
and expect the quality compared to the car. I want to drive a Porsche, but I just pay for VW Lupo.
Would be great.
Cannot work.
All right.
You pay what you get what you pay for.
That's true. That's true. Yeah. Maybe that's also a shift in mindset at some point, because certainly sometimes it's not that much more expensive to get a bit better product.
And if you buy something cheap, you buy it twice.
Sure. Well, thank you very much for your time and your expertise here on this panel. I am very glad to have these experts here. And if you are interested in more deep dive technical stuff, stay tuned. Tomorrow we will be talking about design for manufacturing and manufacturing driven design. So if you want to know what manufacturing driven design is, stay tuned.